In this video, I will show you our experiment, which is a shortening experiment. Basically, you cannot believe it. So this is a tiny little motor. This is a DC 3-volt toy motor. Today, today in this video, I will show you how you can use this motor as a generator. So it can, voltage, some kind of voltage. We can turn on the DC volt, turn some kind of load with this motor. So all of this output is some source of 3 to 5 volts output with 500 milliamps to 1 amps. So I think that one wire of a motor is there, and otherwise also broken. Because I tried this experiment for full day. Right now I can blow this wire in 1 hour just for testing. Now I attach this wire with one other wire, which is connect there and connect there. So it means motor chassis is right now one of the terminal. So I can connect this, touch this. First I take the old this set. First wind the set. 3 volt range, and see, now I wind the thread with opposite way, just as below motor take it and wind it something like that. Now now it's okay. Now grab this wire to join this chassis of the motor. Now need a thread and pull out at once one shot. So you can see it needle goes more than 3 volt. So you can produce more 3 to 5 volts somewhere with output run with 500 milliamps to under 500 milliamps, 7 milliamps, which means 1 amp. But it is a quite interior word. Not that this wire, then because this wire slip out. Well, usually the slip will move out. Now attach it like this, and now wind the thread. Now I'm sure thread wind is only one way, like this way, opposite way. So this motor is similar to RT because when you rotate, polarity is depending which direction you can rotate the motor. And motor output is still DC, not AC. I can widen thread. This time we not need a double or triple the thread because this motor cannot hold double triple thread, or it's not beta thread where I turn test. Then now next it's some thread will slip in my hands. Then now grab the thread tightly and wind. I think it is enough to wind. Oops. Accidentally and finish the thread. Once dry and grabbing it. Now let this wire into there with chassis of the motor. Right now I am lose this thread because I did not holding this thread, otherwise it's not pull out easily. So you can see I did 5 volt. Now I check the current test. The black wire is positive. This red wire is negative terminal and black is positive because this time I use opposite polarity, and there's first plug in 0.6 milliamps range. Now I open it. Now test short circuit. So right now I didn't wind the thread. Threads didn't slip to my hand. Wind the thread. I think it is enough. Slip of the thread. Little bit wind more. Just slip out. Now test. And now let this one wire, remaining one wire to the chassis of the motor, and now take this thread showing in the meter. Thread is not so tightly wind, so that's why when I pull it, it is then remove to top side. So because it is not a pulley, I attach them, so that's why there's a little bit trickier to pull the thread because thread are slip instead of unrolling it. So wind the thread again. Let's see how much time it is made it. I know. I hold the thread to right, show the meter. You can that output at a 1 amp range. This time is showing the upper scale because it's now when once again more set fully now all the thread and once minute this part. Now pull it. Oops. Thread is broken. I not expect there's a thread broken, but it's so broken. I think thread is not properly wind, so that's why it is brought out. Now pull with other way. Somewhere 2.5 amps. So somewhere it can output are milliamps, not more. Now test this motor with power supply. Accidentally my power supply turned off, but I'm on pause. Now I turn on the power supply, set 5 volts, and now I'm seeing this motor. Show you, it is working motor. It's not even working. Back. Now, this is one wire. So you can see it's working. It's still there 80 milliamps somewhere, but my meter, this meter in power supply is showing amps saying. So meaning there are amps, which means amps, and there is under milliamps, under milliamps, and there's less than 100 milliamps. So which means it is then, if 1000 milliamp is more than 1000 milliamp, it can show 1 amp, and below them 1000 milliamp, it can shows some 0.1 or 10, and if more than 100 milliamp, it can show in 0.07 or 0.0 some. So it means 70 amps it can milliamps can draw. So it means which I can draw more than 300 milliamps. So it is voltage amp is 3. It is okay for the uses because this motor can running current is 370 milliamps, and which current I can generate with this motor is, which is a more than which current it can need to for running. And this in this video, then we demonstrate pause.